I forgot to record. Okay, so we're talking about same situation, same girl, same grade, same wood block. Okay, the wood block is still at the same distance, but the only thing that changes is the velocity. So in the data, we're gonna write everything that the exercise is giving us. They're giving us an initial velocity of 15 meters over second, and it's the same direction. Same direction implies the same angle of 45 degrees that we had in the exercise before. Okay? Now, it says, okay, about the position, the vertical position, we have that sheet, which is there exactly on the bridge. If you take a look to the Cartesian plane, this is your x-axis, and this is your y-axis. Okay? So this point right here, where she is exactly the place she's throwing the stone, that is what we know as the origin. Okay? The origin of the Cartesian plane. The origin has coordinates 0, 0. It's telling me an initial position, an initial position in y to be 0, and an initial position in x to be 0 because it's the origin. Okay? I'm gonna move this here. That's what the position over there is telling me. So I'm going to write here my initial y, which is 0 meters, and my initial position, that is also 0 meters. Now, the final position, this is the initial position, and the final position, you don't know where it's going to be. The only thing that you know is that it could be before the stone, the wood block, on the wood block, or after the wood block. But as you can see, still on the river surface. Now, what final vertical position is that? The vertical position indicates that is 20 meters below the original position. So the final position in the vertical axis is going to be 20 meters below. Below means negative. So this will be the final position in y, 20 meters below. In other words, this is negative 20 meters. Now, our target is located
13 meters.
exactly 13 meters from the bridge. So I want to know what all my displacement is going to be. Okay? So I can compare with the target to see if I can finally hit the wood block. Okay? So another given that is implicit here and I didn't write it is gravity. Gravity is always implicit in this kind of problems and is negative 9.81 meters over second to the second power. Having all your data already organized, it's time for us to move on. I'm gonna zoom out a little bit. Do you see the screen very well or not?
Yes, good.
I see it okay.
Okay, great, thank you. So let's see. No, okay. Okay. Sorry. So let's see. I'm gonna work here again. Now that we have everything organized, we say solution. We need to do all the procedure. I don't know if you listen to me well from there. I'm gonna try to move the microphone.
Not so well.
Oh, okay. Is that I'm a little far from the screen? Okay. Does it sound better now?
Yes.
Yes.
Okay, thank you. So in the first step, we always do this, okay? We always get what we know as the components of the initial velocity. That is going to be the first step. And according to the formulas that I gave you, remember that I asked you to keep the formulas in a separate sheet of paper or in a index card or a piece of construction paper. So the first step is apply the formula to get the components of the initial velocity. So I have my two initial velocities. My stone is moving horizontally but also vertically. So I say B initial velocity in x is equal to the initial velocity cosine of the angle. And in y is almost the same. Instead of using cosine, we're going to be using sine. Now we replace by the data provided in the problem. So this is going to be 15 cosine of 45 and 15 sine of 45 degrees. How much did you get?
10.61 per
10.61 meter
second.
per second.
Exactly 10.61 meters per second, both. The reason why we got the same answer is because of the angle. If the angle changes, okay, if it's not 45, then you will see that the two components are going to be different. Now, let's analyze where the stone is going.
Down.
Down, so
The stone
This
is
x is negative.
exactly the stone is going to the right, but also is going down. Okay, so because it's going to the right, it's going to be positive in x, and because it's going down, it's going to be negative in y.
Negative.
So I'm going to write that this is because it's going down, and it's positive because it's going to the right side, like that. After getting the components, you analyze, okay? Remember that I gave you the list of formulas. You cannot get delta x because you don't have the time. That's like the barrier that we have for this exercise. We don't have the time. So we need to use the formulas that are not using time. Okay? So the purpose of the next step is we need to find the time, but to find the time, we need to use the data that we have. So according to the information that we have, take a look. I have initial and I have the final position in y, which means that this gives me information about delta y. Having um, those two data, it's given me that I can get easily delta y by applying the formula that is not included in the list of formulas that I gave you, but you know that every change in whatever is going to be final minus initial. It could be delta time, it could be delta x, for example, is going to be whatever, okay? You need the final minus initial. So you can get it here, final minus initial, and we analyze what we have. It says y final is below, so it is negative 20.
Negative 20 minus 20 minus 0.
Minus 0, okay? So in the end, delta y is going to be just negative 20 meters. Now, using all the data that we have, okay? We have an analysis, okay? We have delta y, we have the velocities, vix, viy, okay? We have the initial velocity without its component, we have angle. So we're going to analyze everything that we have, and we have, of course, the gravity. So, according to everything I have, I need to analyze what formulas I can use. Okay? I don't have the time. So let's analyze the formulas that I gave you the other day. So, let's see. Sorry, I don't have my mouse with me. Okay, nice. Finally it worked. Take a look. I'm gonna focus. I have to go for the mouse. I'm gonna focus on the equations that don't have time and instead use other data that I already know. So take a look right here. Take a look right here. This is the equation, the main equation that I have to use, okay? This is the equation that I have to use to solve that problem. But I cannot use it yet because I don't have the time, okay? So I need to look for the time. Now, the only other equations that have delta t, not Ty max or T air, no, T delta T, are the following formulas. Final velocity in y, okay, it's giving me delta T. And also, the formula for delta y is using delta T over there. Nothing more. Those are the only two equations that we could use. The reason is because I have the time, okay? I need to get the time. Now, the reason why I told you not to use this one is not because it's impossible. No, it's because it takes longer. This one I suggest not to use it unless it is absolutely necessary, okay? Because the time is raised to the second power. That's the reason, okay? That means that we have to isolate for the quadratic formula and find for the time. So I suggest to use this one. Okay, I suggest to use this one. The reason is because it is easier to isolate for the time. So I'm gonna take that equation with me. Okay, I'm gonna take it and I'm gonna just write it. Is final velocity in y equals initial velocity in y plus gravity delta t. Okay, I'm writing the other formula too. Okay. So these are the two equations that I can use, okay? I want to know the time. I can get it from here. And let's work. Let's see if I can use it now. It says final velocity in y equals initial velocity in y plus gravity time. But there's one big issue right here. Because I don't know the time, but I also don't know my final velocity in y. I cannot use it yet. So I'm gonna leave this here and I'm going back with my formulas. Remember what we're looking for. We're looking for the time. Okay? Sorry. We are looking for the time, but also because we don't know the final velocity in y, we need to find the final velocity in y. And take a look. We have an equation right there for the final velocity in y, which is this one. It says final.
BFY square.
Uh,
BFY square.
uh, it's it's bfy squared, but you know you can get rid of the square by using a square root,
The square
okay?
root.
So I'm gonna write this equation now. bfy to the second power equals biy to the second power plus twice gravity delta y.
Please,
Yes.
the second power will be after the F.
Yes. Let me show you. This is a single term. Este es solo un solo término. Se lee velocidad final en y. This is another single term. Velocidad inicial en y. ¿Ok? Entonces es como si tuviera this in parentheses, like that. But as I told you the other day, we cannot use that equation because it is raised to the second power, so we need to use the square root. So I totally suggest that you have to arrange your equation and keep it like that, okay? Keep it like that because this square is deleted with this square root. So in the end, the equation already isolated is going to be this one. It's not going to change. This is going to be the equation. It's not going to change. So if you can add this equation already isolated, keep it with you. Okay? So take a look. I still don't know my final velocity in y, but I can get it. So I'm going to write the process here. Find the final velocity in y in order to get the time, okay? And the purpose to get the time is to get the delta x. That's the final purpose, okay? So the first step will be to get the final velocity in y. The second step will be to get the time. And the third step will be use the 2 in order to get the delta x. So we apply the formula bfy equals everything like that. Okay? And now just substitute by the givens. I totally suggest to do this procedure, exactly this procedure answer in your calculator in this moment, because you will see if you get the same answer or not. So it says initial velocity in y,
Negative 10.61 meters per second.
negative 10.61 meters per second
Square.
raised to the second power, okay, plus 2 gravity, that is negative 9.81 meter over second square,
Negative 20 meters.
and delta y is negative 20 meters. Now take a look. You're going to solve this power. This one you won't, because that square is only from the unit, not for the number. Okay? The only power that you use in this formula is this one.
The one after the parentheses.
Only the one after the parenthesis. The one that is inside, never. Okay? How much do you get inside the parentheses?
504.97.
Meter square over second square.
Square root of 504.97 square meters over square seconds. Okay? And then you apply the square root of your answer, and I get that the final velocity in y equals 22.47 meters over second. Now,
Negative.
we need to put the negative because the stone is going down. So, remember that the square roots can give you plus and minus as an answer, okay? So we're going to choose the negative because the stone is falling down. Remember this. The stone is falling down. So this is your final velocity in y. Now we need to move into the next steps. Okay? Remember, now that you have the final velocity, you can get the time. Now, what equation am I going to use to find the time? I can use two equations, okay? Two equations involve time. Could be this one or could be this other, okay? Now, I'm going to delete this. Okay. I cannot use this one because I don't know what delta x is and I don't know the time. So I cannot use the equation number 1. But I can use the equation number 2 because I know the final velocity in y, I know the initial velocity in y, and I know the gravity. So here I just have one unknown, which means that is my other step, okay? I need to find the time from that formula. You can use already the isolation that I'm gonna give you. Now we're gonna find the time, because then we need to get delta x. Okay? So we're gonna use the equation number 2, the one that says final velocity in y is equal to initial velocity in y plus gravity times. And we isolate for the time. The time will be equal to final velocity in y minus initial velocity in y divided by gravity. Now this equation, you can also write it in your index card. That isolation works, okay? So you can use that. So you say delta t is equal to final velocity in y. We got negative 22.47 meters per second minus from the formula initial velocity in y,
Negative 10,
that is
61 meters up.
negative 10.61 meters per second. All this divided by the gravity, that
Negative
is
9.
negative 9.81 meters over second to the second power. Now, remember this, negative and negative makes a positive. How much do you get from this? How much do you get from this?
The last answer is gonna be 1.21. But just the first part is gonna be negative.
Mhm.
11.86.
Exactly. The first part is going to give you a negative. I got negative 11.86 meters over second. All this is divided by the gravity, which is negative 9.81 meters over second to the second power. Cancel meters with meters and these seconds with one of these seconds. And in the end, the time is going to be given in seconds.
1.21
1.21 seconds.
1.21 seconds. As you can see in this exercise, it's taking less time to reach the river because the sun was turned at a higher speed. It was 12, now it was 15 meters per second, though it reaches the river faster. Now, once you have the time, the purpose is to find delta x. And the equation for delta x is probably the easiest. Delta x,
Miss,
yes?
uh, I use, for example, for the time, I use the VIY and I also isolate for the time. So I divided the negative of V initial times the angle divided by the gravity, and it gives me
Yes.
different. But
Oh, no, really? Send me a picture of your exercise so I can help you after the class.
okay, Miss.
So, the equation for delta x is the one you see over there. Very nice equation, very simple to use. Just substitute by the givens that you have. And, okay, VIX is the first component that we got, that is 10.61 meters over second. Is positive because it's going to the right. And the time that we got from the step before, that is 1.21 seconds. Here you cancel seconds with seconds, leaving you the remaining unit, just the meters. Delta x, how much is that?
12.84 meters.
12.84 meters. So now we need to answer. Does she hit the wood block? Yes or no?
No.
No.
No. It's
Almost.
missing almost. Almost. It's very close. probably hit on the corner, but but we don't know it because we don't know the size of the wood block. Okay, so to answer this, we could say that probably the rock reached over there. Still very close to the wood block, but not entirely. Okay, so if it gives you 13 meters exactly, or 13 meters point 0.02, 0.03, even 0.5, I think that you can answer like yes, it hits the wood block. But if it's missing quite a lot, like 15, 16 centimeters,